So this is the most important thing that this is bipolar. Bipolar means junction transistors. So practically it looks like this. It is having the structure. So we have N, P, and N. This is N positive, in fact, right? Now this is to be separated by insulators. Okay. In between them, we have metal contacts here. If I say, right? अब ये क्या है? This is silicon dioxide. Okay. ये एल्युमिनियम के बने होंगे. This one is nothing but this is aluminium. Aluminium है वैसे. And if I see this, these are insulators. Okay. So that this metal is not going to interact with the another. इनकी आपस में कोई interaction ना हो. So we have this contact that is called as collector. This is called as base, and this is called as emitter. So this is emitter, base, and collector. Like BC547. ठीक है? ऐसे रहते हैं. Emitter, this is E, this is E, this is base, and this is collector. So emitter is having the highest doping. If we talk about emitter here, highest doping, right? Base is lowest token, right? From size point of view, say collector is largest, right? And base is smallest. So if you see this, this is N, right? So this is emitter, this is base, and this is collector. Have you seen transistor? कभी देखा आपने?
Yes, sir.
Yes, sir.
Okay. यूज किया कभी?
No, sir.
सर प्रैक्टिकल में था कॉलेज के टाइम.
Okay, okay, right. Okay, so this emitter name is emitter means which is emitting something. And what we are emitting here in case of this, emitting electrons, right? Collector means collecting those electrons. That's why, because it has to collect, so it's largest in size. सबसे बड़ा यही है ना, you can see. Okay, ठीक है. बट आपने तो इस तरह का स्ट्रक्चर देखा होगा, if you see. है ना, बुक्स में इस तरह का होता है ना.
Yes, sir.
Yes, sir.
ठीक है. बट रियल स्ट्रक्चर इज दिस इज द फैब्रिकेटेड स्ट्रक्चर. प्रैक्टिकली ऐसा होता है एक्चुअली. ओके, प्रैक्टिकली इट इज लाइक दैट, है ना. So you don't find this in common books actually. Okay, then what is this? तो ये क्या है? अब बुक्स उठ रहे हैं तो ऐसा क्यों नहीं है फिर? में से इससे ये कैसे बन गया?
सर ये डायग्रामेटिकली ऐसा डिपिक्शन है हमें एक्सप्लेन करने के लिए कि एक्चुअली ट्रांजिस्टर वर्क कैसे करते हैं।
अच्छा, ऐसा है ऊपर वाले से। बल्कि ज्यादा आसान लग रहा है ना? ये तो बड़ी मिसलीडिंग सी है। ये तो तीनों एक जैसे लग रहे हैं, ऐसे दिखते हैं ना एक जैसे लगभग। इसको थोड़ा छोटा कर देता हूँ। कुछ इस तरह से बनाया होता है जनरल बुक्स में, है ना? बल्कि एमिटर और कलेक्टर तो ऑलमोस्ट सेम से दिखाई देते हैं। ओके, reason being this is nothing but this is a model actually. This is transistor model we are using, right? Or because now if we talk about this, okay, so basically this is being used, this portion actually here, this is only used to explain this. It is something like that. अगर इसको अगर आप देखो, so this base is smallest one, ठीक है? emitter में अगर थोड़ा सा मैं change करता हूँ, emitter is having this portion, right? And collector, if I am depicting it like this, okay? So I think now you can see this is collector, right? This is emitter, and this is base. This is what they are using actually. So this is vision of this model basically, right? And the question arises why we are doing this, because for better calculations, better and simpler calculations, we are going to modify this into this, इस तरह से होगा. And n positive means it is having the highest doping, right? So this is emitter, this is base, and this is collector. And if you see the transistor, we see 547. So can you see my screen?
Sir.
Yes, sir.
Yes, sir.
So you can see the, this is how it looks like, emitter, base and collector. तीन पिन ऐसे निकले होते हैं बाहर. ये फैब्रिकेशन स्ट्रक्चर से ही है जैसा भी. ओके, and it is packed inside a plastic can. मेटल कैन भी रहती है, प्लास्टिक की भी रहते हैं, right? So if you see advanced process technology, low error voltage, fast switching speed, full voltage operation, high power and current handling capability. So if you see continuous collector current is 100 milliampere. दिख रहा है? So this is how it looks like. Okay. So we have to understand its working, that how it is going to work. So there are three reasons of this, and because its name is bipolar, so current is here is because of electron and holes. Current is because of these two factors. That's why it is bipolar in nature. Okay. Junction means it has two junctions. Junctions. Junction means p and junctions basically. Okay. I'm saying J1 and J2. तो कहाँ कहाँ है J1 and J2? So this is junction here, and this is another junction here. Am I right?
Yes.
Hello. So this
Yes,
is
sir.
I'm saying junction J1 and junction J2 because this is NP here, and this is PN type here, PN type here. So two junctions, PN junctions are here. That's why it is bipolar junction. Third one is transistors. So I hope आपको पता होगा. I am just repeating these things. Transistor means that word is made from trans resistance. Transistor. Transfer means means transfer of signal from one resistance to another. Okay, right? That's why its name is transistor. Means suppose this is input side and output we are taking from here. So input signal है because अगर मैं बात करूं, if I talk about this, I'm saying this is 10 to the power 21 doping level. This is 10 to the power 17, and this is 10 to the power 19. Okay, so junction J1 is having higher resistance or junction J2 is having higher resistance. कौन से ट्रांजिस्टर देर आर एक तरह से आप देख रहे हो वी हैव टू डायोड्स हियर तो कौन से डायोड की रेजिस्टेंस ज्यादा होनी चाहिए राइट डाउन योर आंसर इन द चैट बॉक्स कि resistance of J1 is higher or resistance of J2 is higher. If doping level of this emitter, base, and collector are given like 10 is to the power 21 per centimeter cube. Can you write down your answer? You understand my question, na? Hello? Hello?
Yes, sir.
तो कौन सी रेजिस्टेंस ज्यादा होनी चाहिए कौन से पीएन जंक्शन की J1 वाले की कि J2 की किसकी रेजिस्टेंस ज्यादा होनी चाहिए जिसकी डोपिंग ज्यादा है कि जिसकी डोपिंग कम है बिकॉज बेस इज कॉमन टू बोथ। ठीक है, तो किसकी डोपिंग कम है?
सर J1 की ज्यादा हो
हेलो,
रेजिस्टेंस।
नहीं, एक्चुअली क्या है,
G2
J1 is having higher doping. Higher doping means it is having more free available charge
conductivity.
carriers. That means
More
इसकी
conduction.
conductivity ज्यादा है, तो resist, हाँ, more conduction means less resistance, isn't it? So RJ1 is having less resistance than RJ2. So that is how we are going to do it. तो it depends कि कैसे कैसे यूज करते हैं आप। अगर इनपुट ऐसे देते हैं ना, okay, so this is low resistance and this is high एक तरह से। So we are transferring the signal from low resistance to high, means अगर I low होगा, लो करंट को अगर हाई रेजिस्टेंस की ओर ले जाएं, so which voltage is large, this one or this one? Vj1 is equal to Rj1 I1, Vj2 is equal to Rj2 I1. Which one is larger?
VJ2.
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 Vj2. Okay, so means we are able to increase the voltage। ऐसे ही कर रहे हैं ना, अगर यहाँ सेम करंट है, this I current and this I current, if both are same, we are transferring this here to, but it is the resistance which is changing. That means that is why we are saying it as transfer of signal from one resistance to the another. That resistance can be low to high, उसी का फायदा रहता है, क्योंकि current is like this, suppose I am saying it is same। Okay, so I hope you understand the meaning of this bipolar junction transistor now। Understand?
Yes, sir.
Yes,
ये
sir.
तीन चीजें हैं जो इसमें काम करेंगे। ठीक है, अब इसका ऑपरेशन क्या है? वेरी सिंपल। ये कब इसमें एक तरह से दो जंक्शन है, मींस जंक्शन मींस टू स्विचेस, बिकॉज द डायोड इज आल्सो स्विच, स्विच की तरह ही है ना,
Yes, sir.
क्यों? ठीक है, तो जब या तो ये ऑन होगा या ऑफ होगा, राइट? ऑन होने के लिए इसको फॉरवर्ड बायस होना पड़ेगा, ऑफ होने के लिए इसको रिवर्स बायस होना पड़ेगा। ओके, so we learn its operation, that how it is going to work। So we'll see that how it is going to we work like this before, although now we talk about transistor action। So we know that this is suppose transistor, this is, we know, N positive, this is P, and this is N negative because it is collector। Okay, now if we see this junction and this junction, right? Okay, I have to make it again. इस केस में क्या है कि if we talk about this, because doping is high in case of emitter, so its depletion region that is small because of the high doping there is large number of free charge carriers and the electric field is becoming larger as compared to the another p-n junction. This इस केस में so there is no further movement of the charge carriers in this case. This is junction J1 and this is junction J2. ये junction J2 है. So because emitter doping is highest, so emitter के केस में ज्यादा doping है और collector के केस में कम doping है. So this is base. Okay. So J1 is depletion width of J1 is less than width of J2. Okay. And if we see these three, because अगर इसकी बात करें in terms of let me take a photo of this. Right. This one. Okay. So you can see here. Can you see this?
Yes, sir.
So this region is smaller and this region is a little bit larger. है ना? Now if you see, because this emitter is having higher doping, right? So its Fermi energy level is, because if we have higher doping, that means availability of charge carriers is possible in the conduction band. If it is having or Fermi level means that below this energy states are occupied and above this energy states are unoccupied. So more energy states are occupied, that's why it is having higher energy level. But in case of P base, because doping level I'm saying 10 is to power 17 and this is 10 is to power 18 suppose, right? So it is having lower energy Fermi energy level, and because it is 10 is to power 18, so थोड़ा सा ऊपर है इससे. Okay, because below this all the energy states are occupied and above this all the energy states are unoccupied. Okay, but when we combine all these three regions n p n, suppose what is going to happen? हम ऐसे नहीं बोल सकते ना that this energy level is going to align actually. This one, this is going to be aligned actually, because below this all the energy states are occupied, and above this all the states are unoccupied. This is what is the definition of Fermi energy level. Okay, so we are having we know this is and this is the depletion region, that how this is a positive side है, ये negative side है, ये positive है, ये negative है. तो दोनों के depletion region, they are having different size, right? Now the free electrons in the n positive region diffuse into the adjacent p, because यहाँ से जो भी free electrons होंगे वो इधर shift करेंगे, right, to so यहाँ पे junction बनेगा, positive charge carriers, or we can say the holes, they are being created, right? And electron इस side diffuse होना शुरू होंगे, because here electrons in this p base is plus, here electrons is very high, so अपने आप diffuse होना शुरू हो जाएंगे इस side को, ठीक है? And holes, because इस side कम होंगे तो holes opposite direction को, and same is true for this junction also, that they are going to move opposite to the direction. So this is going to create a barrier. This is that barrier basically. ये वो barrier है, this one, because this is one energy level, this is another energy level. And if I can tell you here, this one, this hill type structure, that means there is a barrier between two junctions, because this is N, this is P. So एक और दूसरे के बीच में इतना फर्क है. Potential means it is the energy basically. You are placing electron at a height h, suppose, right? And another one is और ये एक तरह से ऐसे है कि one is at height h, another one is h1, and another one is at height h2, and that is the change in the potential energy. That's why it is called as potential, or difference between them is called as potential difference. Okay, so potential energy, if you row, it is mgh in case of some object, and in case of electron actually. Okay, so physics में ऐसे पढ़ा होगा ना आपने, for the larger objects where this g is coming into picture. Here in case of atoms, there is this potential energy. This is something what we know. Voltage is equal to E by D. ऐसे करते हैं ना, how much potential we are applying. But here the placing of the electrons, because electrons is having energy and there is difference between them. Okay, and how electrons are being placed, that depends upon the doping level, because how many free electrons are available for us, and Fermi energy level is deciding the number of occupied states below or above this. So below it all filled, and above this all are unfilled. So these potential barriers, they are going to tell us that how much is the, or how we can proceed from emitter to the collector, कि इलेक्ट्रॉन, कोई भी इलेक्ट्रॉन है emitter से collector तक कैसे पहुंचेगा. This depends upon these barriers, and these barriers, they are depending upon their doping levels. Okay, so we'll continue with the operation, because I think operation में थोड़ा सा time लगेगा. Okay, ठीक है, so we'll talk that in the next class. Any questions from today's class? हेलो।
Yes, sir.
हाँ जी, बोलो।
सर बाइपोलर कहने का मतलब है कि वो जो इलेक्ट्रॉन्स और होल्स के बारे में बात कर रहे हैं ना।
हाँ, कि करंट जो है इट इज बिकॉज ऑफ इलेक्ट्रॉन्स एज वेल एज होल्स, है ना। उसमें दो तरह के करंट होंगे एक्चुअली, राइट।
यस सर।
ठीक है, इसलिए उसका नाम बाइपोलर है। जैसे इफ वी टॉक अबाउट मेटल, मेटल में कौन करंट यूज होगा? होल करंट होगा मेटल में। हाँ जी, नहीं ना। हेलो, एम आई राइट?
यस।
वो यूनिपोलर है। ठीक है,
यस सर।
तो वो क्या है? यूनिपोलर। हाँ जी, और कुछ?
सर ये लास्ट वाला एनर्जी डायग्राम नहीं समझा।
हाँ, अभी इसमें और भी बताएंगे हम, थोड़ा सा इसको देखना आप दोबारा सा ना, कि क्योंकि इसमें क्या है कि एनर्जी लेवल्स हैं, जैसे तीन तरह के ना। कि मान लो जैसे दिस इज द कंडक्शन एंड, ओके। अब इसमें फर्मी एनर्जी लेवल है, बेसिकली फर्मी एनर्जी कुछ नहीं है। विद द हेल्प ऑफ डोपिंग यू कैन इंक्रीज और डिक्रीज दिस, मींस व्हाट यू हैव इज, जैसे एन टाइप डोपिंग करते हैं ना, तो है फर्मी एनर्जी लेवल। बिकॉज जैसे फास्फोरस है, मान लो, so phosphorus is having 0.045 electron volt activation energy, basically means this much of energy required for electron inside the phosphorus to get free for, इतनी की एनर्जी चाहिए। बट अगर यहाँ कोई इलेक्ट्रॉन है, उसको कितनी चाहिए? 1.1 इलेक्ट्रॉन वोल्ट। ओके, दैट्स व्हाई वी डू द डोपिंग एक्चुअली। सो व्हेन वी डू द डोपिंग, तो इलेक्ट्रॉन की एनर्जी यहाँ पे होगी, तो दिस EF is shifting towards this side. Reason being, because position of EF means energy states are vacant and below this energy states are occupied. अगर मैं EF को यहाँ रखता हूँ, मान लो नीचे रखता हूँ, वही रहने देता हूँ जहाँ पहले थी सेमीकंडक्टर्स की, इंटर सेमीकंडक्टर की यहाँ है। आई एम सेइंग दिस इज फॉर द intrinsic semiconductor. This is called as EFI. लेकिन जैसे डोपिंग की, दिस इज गोइंग टू शिफ्ट टुवर्ड्स अपर साइड, क्योंकि और एनर्जी स्टेट्स ऑक्यूपाइड। तो डेफिनेशन ऑफ ईएफ क्या है कि बिलो दिस ऑल द स्टेट शुड बी ऑक्यूपाइड। ओके, तो दैट्स व्हाई इस केस में, इन केस ऑफ एमिटर, ये ऊपर है, यहाँ है बेसिकली। बेस के केस में नीचे है, क्योंकि एक लो डोपिंग है, लोएस्ट डोपिंग है। तो दिस इज हैविंग द लोएस्ट डोपिंग एंड दिस इज हैविंग द हाईएस्ट डोपिंग। ठीक है,
यस सर।
दैट्स व्हाई ये एन पॉजिटिव, राइट। और इसकी डोपिंग भी कम है, लेकिन इससे थोड़ी ज्यादा है, तो इसलिए ये थोड़ा सा ऊपर है। ओके, तो जैसे तीनों को कंबाइन करेंगे तो ये अलाइन करना पड़ेगा हमें। कि ऐसा होता है ना, सो डिफ्यूज, तो इलेक्ट्रॉन एक साइड से दूसरी साइड, यू मेक ए पीएन जंक्शन, क्या होगा? डिफ्यूज आउटर, ऐसा ही होगा ना।
सर आपकी आवाज बहुत कट
हेलो,
रही है। सर मतलब आवाज कट रही है, तो कल ही समझा देना ये सर।
ओके, कोई बात नहीं, ठीक है। to discuss about the operation of the PGT, okay, ठीक है।
यस
Do you have class now? है ना? I think. Okay, okay. Thanks
Thank you,
Thank
sir.
you, sir.
for
Well,
being with me. See you.